All right, today's lesson is on section 11.4, area of regular polygons and composite figures. We're going to start with the area of regular polygons. The first thing that you need to know is that the center of a polygon is actually the center of the circumscribed circle. So here is my polygon right here. I have a hexagon. The center of the hexagon is actually the center of the circle that has been circumscribed. So here's my center. Okay. The next thing that you need to know is that the radius of your polygon is the distance from the center to the vertex. So this is the radius. And then the last thing that we're going to talk about is the apothem. We're going to use this all the time. And the apothem is the distance from the center to the side of one of the sides of your polygon, and it's perpendicular. Okay, it's going to be perpendicular. So this is my apothem. All right, so let's look at this equilateral triangle that is circumscribed in this circle. So the center of this will be right here. This black line that I'm drawing will represent the radius. And this dashed line would be the apothem. Okay? All right. So we have a regular polygon. It has radii and apothem shown. Find the measure of each numbered angle. So let's talk about this first of all. Remember that these are the radius, or radii, because there are multiple. Radii. This is a hexagon. This is a regular hexagon. And we're going to be asked to find things like the measure of the central angle, which is exactly what number 1 is. Number 1 is the measure of the central angle. Let's see this. Remember that this is kind of sitting inside of a circle. So if I think about the number of angles, I have 1, 2, 3, 4, 5, 6 angles. So I can take 360 and divide by 6, and I find out that the measure of angle 1, which is also the central angle, is 60 degrees. Okay? I can also find the measure of angle 3. I know that these are regular polygons. The definition of a regular polygon is that all the sides are the same measure and all of the angles have the same measure. So a hexagon is divided into 6 equilateral triangles. So the measure of angle 3 is also 60 degrees. The measure of angle 2 is actually 1/2 of the measure of angle 1. Okay, we're just finding the measure of each numbered angle. Remember, important, this right here, central angle. Don't forget that. Remember, central angles have the same measure. Okay, so the area of a regular polygon, this is a formula, is half the product of the apothem and the perimeter. Write it like this. The area of a regular polygon equals 1/2 times A, little a, for apothem, times P for the perimeter. Okay? So we're going to find the area of a regular polygon with 20 12-inch sides and an apothem. So first of all, this is a 20-gon. I know that the apothem is 37.9 inches. I don't know what the perimeter is, but I could probably find it. Let's see, the perimeter is the sum of the sides. It has 20 sides, and each one of them is 12 inches. So I know the perimeter is 240 inches. So if I wanted to find the area of this regular polygon, I know that the area equals 1/2 times the apothem, which is 37.9, times the perimeter, which is 240. So the area of this 20gon is 4,548. 4,548. A library is a regular octagon. Each side is 180 feet. Each side is 18 feet. So I have that marked for each side is 18 feet. The radius of the octagon is 23.5 feet. We have to find the area of the library to the nearest tenth. I think we're going to need to do some trig functions here. So let's see. Can we find the measure of this angle? So I'm first of all going to draw that little triangle. So I'm actually going to draw it as one big triangle. So does everybody see this? This is actually a triangle right here. Okay, so that's what I have drawn. This is 18, and I know that the radius from the center to one of the vertices is 23.5. I need to find x, which is the apothem. And the only way I can do that is if I know y, that measure. So let's think about a trig function. First of all, we need to find out this angle measure, and we can do that because we know that there are 8 triangles, or 8 little angles inside of that circle. So I'm going to take 360 and divide it by 8. And I know that this whole angle right here has a measure of 45 degrees. Now, when I drop a perpendicular to find the apothem, I'm cutting these in half. So I know that this is 9 feet, and this is half of 45, or 22.5. So what can I do to find x? Well, let's see. This is the opposite over the adjacent, so the tangent of 22.5 equals the opposite over the adjacent. So really I have 9 divided by the tangent of 22.5 equals x, and that comes out to be about 21.72. Actually, let's do that, 21.7. Okay, so I could also maybe, you guys know that this is 23.5, so you could use the Pythagorean theorem. I guess I don't know why I think about that. It could be like that. Anyway, so now let's find the area. Remember that the area equals 1/2 the apothem times the perimeter. I'm going to erase these little pictures I have here. So the area equals 1/2 times the apothem of 21.7 times my perimeter, which is 18 times 8. There, it's right here. let me try that again. 21.7 times 18 times 8 equals 502. Decimal point in the wrong spot. Let's erase that. 1,562.4. How about that? Okay. You guys were classically you would correct. Okay. Let's find the area of the regular polygon with the given radius or cosine. So here I have a regular polygon, which means all the sides are the same. So I know that these are all congruent right here. And it has an approximate base. So the first thing that I'm going to do is just draw that little piece. I'm just drawing this piece right here. Okay. I know that this is 8. I know that this is originally 60. So it now is 30. And I need to find this because this is going to end up helping me figure out my parameters. Alright, so I can do a couple of things. I can remember what I know about a 30, 60, 90, because that's what this triangle is. So I know that if I have a 30, 60, 90, the short leg represents N. The long leg represents 2n, and sorry, the hypotenuse, and the long leg represents n root 3. So if n is 8, then this other side is 8 root 3. So that means that this is 8 root 3, and this is 8 root 3. So the whole side is actually 16 root 3. So the perimeter is 16 times 3 or 48 root 3. So the area equals 1/2 times the approximate times the perimeter. So 1/2 times 8 times 16, times 48 root 3. Half of 8 is 4. 4 times 48 is 192. It says if your answer is not an integer, keep it in simplest radical form. So my answer is 192 root 3. Here's what I'm doing. Let's figure out. Area of the trapezoid equals 1/2 B1 plus B2 all times H. Well, the first thing I'm going to do is I'm going to look at this little triangle that's taken out of it. And I know that this is 2 and this is 6. I can drop a perpendicular. So this is 1. And I'm going to use the Pythagorean theorem to figure out this measure. Okay, so I really have 6 squared minus 1 squared equals x squared. 36 minus 1 equals x squared. The square root of 35 equals x, and that is about the nearest tenth. 5. I'm going to keep it there for 5.9. So if this height right here is 5.92 plus 1, the height of my trapezoid then is going to be 6.92. Okay. Okay. So I'm going to find the area of the trapezoid, and from it I'm going to subtract the area of this triangle. So the area of the trapezoid, I'll let a little t equals 1/2 times b1 is 8 plus b2, which is 12, times the height, which is actually 6.92. So half of 20 is 10. So my area of my trapezoid equals 69.2 centimeters squared. Now remember, from that I have to subtract out the area of the triangle. So let's find the area of this triangle. For the area of the triangle, I have 1/2 times the base, which is 2, times the height, which is 5.92. So the area of my triangle equals 5.92 centimeters squared. And I'm just going to subtract the two values. 69.2 minus 5.92. So the area of my composite figure is 63.28 centimeters squared. Okay. This next one is much easier because it is a height. So I have a parallelogram. The parallelogram, remember the area for a parallelogram is just base times height. This is my base, this is my height. So 14 times 9, which is 126. And from that, we're going to subtract the area of the kite. I remember that the area of a kite is 1/2 b1 times b2. That's of course spring break. Diagonal 1 is the same as the height, 9 feet. So 1/2 times diagonal 1, 9 feet, times diagonal 2. This is parallel to the top. So it's all the same measure. Which is going to equal 63 feet squared, 126. Area of the parallelogram minus